Hello, my name is Cody Shearrow.
And I'm Josh Stevens.
And this is our experiment, Flubber in Action.
Here we have 15 milliliters of water in our 100 milliliter of or 100 milliliter beaker with 1 gram of borax.
Additionally, we have 21.8 grams of glue pre-measured with the mix of 20 milliliters of water in a 250 milliliter beaker.
At this time, I'm going to mix the borax with our water.
And I'm going to stir up the glue and the water more.
Borax, when formed in solution, contains the boride ion, as you see on the board.
And glue, as you can see, contains a polyvinyl alcohol that is essential in the forming between the two substances.
At this time, I'm going to mix the borax with our water and glue. Mix that up. While this is happening, the two are starting to link together.
And this is known as cross-linking. And cross-linking is essentially a chemical bond that is formed between two adjacent substances, creating a larger molecule.
This time we're going to knead the slime, but we have pre-made another flubber. And at this time I'm going to demonstrate the stretchability. And as you can see, it stretches far, but after so long it breaks.
And here's our new flubber. And right now I'm going to demonstrate viscosity. And viscosity is a thick, slimy substance and consistency due to internal friction. And this is due to the cross-linking. When this happens, essentially before cross-linking occurs, the atoms are sliding past each other like this. But when cross-linking occurs, it creates a friction in between them. And to show you how this works, I'm going to have a race between the flubber and glue. As you can see, the flubber is taking a long period of time to go from the bottle to the ground. But if we look at the glue, it pours right up. Well,
you don't have the crusty on there. It pours right out.
There we go.
A common household application of a polymer such as our flubber is just the soles of the shoe, and through a process called vulcanization, which is a network of crosslinks, I introduced an elastomer, which is a polymer containing a rubbery substance. Like the soles of the shoe, as it hits the ground, the rubber of the polymer has memory, so that once you lift your foot back off, it returns to its original form.
And as you can see, the flubber is still taking its time going through the bottle. This takes approximately 1.5 minutes to 2 minutes. So now I'm going to demonstrate resilience. And resilience is simply just the bounceability of the flubber. And as you can see, it bounces slightly. As it hardens and needs more, it becomes more bounceable. And a common household application of this would be a grip strengthener, or this can be compared to a therapy ball. And this relates back to cross-linking, because when you squeeze, the atoms are creating the friction for it to reform back to its original shape.
This time I'm going to show you the inflatability of our flubber. You take a straw and you form it around the flubber, you should be able to blow it up. No, you don't. Let's try this one. Take 2. Usually what happens is there's an air bubble created in the flubber, and it kind of inflates like a balloon. Pretty simple. Another household application could be, as reference from mom endeavors, is that you can make your own slime, and you can actually color this with food coloring and make it to a cool slime Halloween decoration.
And the chemical formula can be found on rsc.com, and my application of the grip strengthener can be found on the nuffieldfoundation.org. This concludes our presentation on flubber in action.
Thank you.